This is section 10.2, part 2, where in part 2 we're going to talk about the areas of rhombuses and kites. And as you can tell here as we look at the first part here, you can find the area of a rhombus or a kite when you know the lengths of its diagonal. So as you're looking at the picture here, it says the area of a rhombus or a kite, so both of them have the same area formula, is half the product of the lengths of its diagonal. So if I take the length of diagonal 1 times the length of diagonal 2, and then I divide that in half, that's going to be the area. Now, one other way that we can put that is, again, diagonal 1 times diagonal 2 divided by 2. That's the same concept. Okay? So, essentially what you have to be able to do is calculate the distance of the diagonals and then be able to take the diagonals, multiply them together, and divide by 2. Now, there's also some other things in here as well. Remember that in the case of both a rhombus and a kite, that the diagonals are perpendicular. That's going to come into play here a little bit because you are going to have to use the Pythagorean theorem a little bit to maybe find some distances of certain parts of the diagonals. Okay, so let's take a look here at the very first one. Finding the area of a kite. What's the area of kite KLMN? Well, as you can tell here, KM is one diagonal from K to M, and we see that this part's 5 and that part's 2. So essentially that's 5 plus 2, which is 7 in this case, meters. So KM is 7 meters. LN is the other diagonal that goes across the kite. In this case it's 3 and 3. So you also know that LN is going to be 6 meters. So to find the area, I take diagonal 1, which is KM, 7 meters, times diagonal 2, which is LN, which is 6 meters, and then I divide that by 2. Well, this is 42 meters squared divided by 2, which happens to be 21 meters squared. That's the area of a kite with two diagonals, one of 7 and one of 6. Okay, second one, it says a rhombus has sides 10 centimeters long. If the longer diagonal is 16 centimeters, what's the area of the rhombus? Okay, so now as we look at this here, I'm going to draw a shape because we don't have a shape drawn. So draw ourselves a rhombus here. And we're going to draw the diagonals in. I'm going to draw each diagonal in as a different color here. All right, so it says that has sides lengths of 10, so each side is 10. Because it's a rhombus, we know that the diagonals are perpendicular. And it says the longer diagonal is 16 centimeters. Well, as you can tell, the longer diagonal of a rhombus, in this case, is the red line. And if you also remember things about a rhombus, the diagonals also bisect each other. So in this case, if I know that, I know this length is 8 and this length is 8. Okay? Now, this is where you're going to have to do some investigating because we only know the length of one diagonal. Diagonal 1 is 16 centimeters long. We don't know yet how long diagonal 2 is. But if you look at your triangle here, or if you look at your shape here, you'll see that you have a right triangle with two sides, and you could use any one of the triangles you want. So I'm going to go ahead and redraw this triangle here. In this case, this is the blue line right here. This is the blue line. The red side of the diagonal here is 8, and what happens to be the hypotenuse is 10. Now, I can find the length of the blue diagonal, the half of it, by using the Pythagorean theorem. So in this case, a squared plus 8 squared equals 10 squared. And I end up with 8 squared plus 64 equals 100. And if I subtract 64, I get 36, which means if I take the square root, A is going to be 6 units long. So this side right here is 6 units long. And again, the diagonals of a rhombus bisect each other, which means that that is also 6 centimeters long. So now I can say that diagonal 2 is 12 centimeters long. So I know that the area is diagonal 1, 16, times diagonal 2, which is 12, divided by 2. In this case, 16 times 12 gives me 192. And if I divide that by 2, the area is going to be 96, and in this case it is centimeters squared. So this is a problem where, this case, you had to use the Pythagorean theorem to find the length of one of the diagonals. Okay. Last problem here says the high occupancy vehicle lane is marked by a series of diamonds or rhombuses painted on the pavement. What is the area of the HOV lane diamond shown? Okay, so I know that I have a length here of 6.5 for each one, for each side. And I know that this length right here is 2.5 feet. So I also know then that this is 2.5 feet as well, right there, that other side. Now, again, similar to the last problem, I don't have the length of the other diagonal. I know this is 6.5. I know this is 2.5. I need to figure out the half length there so that I can multiply it by 2 to get the other diagonal. So again, a squared plus 2.5 squared equals 6.5 squared. And it's going to be a squared plus 6.25 equals 42.25, which if I subtract 6.25, a squared is going to be 36. And in this case, if I take the square root, a is going to be 36, or excuse me, not 36. A is going to be 6. Now, is it always going to turn out to be 6 every time you do this? No, it's not. It just happens that these two problems, that was the way it worked. So this is 6 feet long, and this is 6 feet long. So in this case, I know diagonal 1 is 12 feet. That's the 6 and the 6. Diagonal 2 is 5 feet. That's the 2.5 and the 2.5. So the area is 12 times 5 divided by 2, which happens to be 60 divided by 2. So the area is 30 feet squared. Okay, so this concludes section 10.2, part 2, finding the area of rhombus and kites. Don't forget to complete your WSQ.